So we're trying to find the electric field 0.03 meters away from a charge. Drew the charge. I drew the arrows away because electric fields leave positive charges. And I marked some distance x that is, in this problem, 0.03 meters away. So the electric field equation, E equals kq over d squared. So E equals k, which is always 9 times 10 to the 9th. And no, you don't have to memorize it. I give it to you all the time. Q is the value of the charge making the field. Okay, so that's 6 times 10 to the negative 6. As per usual, don't plug in any signs that are here. And then we divide it by the distance squared. Now, instead of being the distance between two charges like it is for forces, it's the distance away from the charge where you're looking for the field. I'm looking for the field 0.03 meters away from the charge, so my distance is 0.03. So I'm just going to plug these numbers and solve. 9 times 10 to the 9th times 6 times 10 to the negative 6 divided by 0.03 squared.
What's the unit of field?
Newtons per coulomb. So we get an electric field to be 6 times 10 to the 7th newtons per coulomb. You might be saying, well, that's a really big electric field. And the answer is yes. But part of that reason is because you're not used to like numbers of electric field. Like if I said, oh, the electric field's 30, you would have no idea if that's big or small. Right? The reason you know 1 kilometer is big is because you've walked a kilometer. You're like, that's a long way. You're just not familiar with these values, so don't worry it doesn't seem too big or too small. Likewise, we're very, very close to the charge. And while 10 to the negative 6 coulombs does not seem like a lot of charge, it actually is a lot of charge. Most charges that you're used to as like standard charges are in the micro to nano coulombs range. Not like 1 coulomb of charge is like redonkulously big. So, yep, 1 coulomb of charge is a lot. Now, here's the question I want to ask you. What would happen if we tripled the distance? So what would happen if we made the distance go 3 times further? So I'm going to resolve it with a distance of 0.09 instead of 0.03, just so we can look at how the values have changed. But I also want you to see that there's another way to do that, which I'll show you here in a second. So if I solve it again, let's do a different color. If I solve it again, but this time I use a distance that 3 times further, 9 times 10 to the 9th. Six times 10 to the negative 6th. Divided by the distance squared. 9 times further is, or sorry, 3 times further is 0.09. And if I solve this one, I get this. So hopefully you could guess that yes, it should get smaller, and it in fact does. But how much smaller is it? So anyone want to take a guess on how much smaller this number is than this one?
1/9.
Yeah, it's 9 times less. And if you're saying to yourself, well, how do I get that? Well, first of all, notice that the power went from 7 to a 6. So when you drop 1 power, that's 10. But it's not going from 6 to 6. It's going from 6 to 6.7. So it's not quite 10 times less. And so it's 9 times less. And if you're saying, well, I still don't get that. Well, here's how you know. It's distance squared. So if I go 3 times further away, I'm going 3 times further squared. And 3 squared is 9. That's how I know it's 9 times less. If I went 3 times closer, it would be 9 times larger. So if you're saying, well, how do I explain that on a test or something like that? Either way, you can either solve it for me, or you can describe what would happen and explain when I move closer, I go distance squared more or distance squared less. Either way is fine. Last thing we need to talk about is direction, because notice I haven't explained any directions yet. Direction is actually very easy. Look at your picture that you made and say to yourself, self, what direction would a test charge go? Test charges are always positive. And they're super tiny, so they don't make their own fields. You just put them in a field and see what they do. What direction would a tiny positive test charge go? It would go away from this charge. So my electric field is 6 times 10 to the 7th, away. If this was a negative charge, it'd be 6 times 10 to the 7th, towards. That's it. That's all the direction is either away or towards. That's it. Okay, I'm not worried about up, down, left, right. Towards or away are fine for the directions. For field, for force, you need specifically positive, negative, left, right, that kind of thing. But for field, it's enough to just say towards or away.